Hello, my name is Milena Tsvetkova, and I'm here to talk to you about online research that focuses on groups and social interactions. Now, there are two ways in which we can approach the social world. We can focus on individuals, consider them independent, and look at certain factors and how they affect individual outcomes. On the other hand, we can also focus on the interactions between individuals. So we can think of individuals as embedded in social groups, interacting with others, and we can focus on how others affect individuals. So I'm going to talk about this latter second approach. Now, how do we do research that focuses on social interactions in groups? So one approach is to look at how the group affects individuals. So here we can think about group effects, and we can think about, say, constraints, certain structural constraints, and how they inform individual behavior, for example. Another approach to look at that is to see what kind of group outcomes we obtain. And we're particularly interested in group outcomes that cannot be deduced from individuals. We cannot just simply aggregate individual outcomes to obtain a group outcome. So here we can think about emergent phenomena such as segregation, collective action, but also inequality if we think of it as a distribution of individual outcomes rather than an average individual outcome. And finally, we can, of course, look at both of these kind of effects at the same time. And we can here think about feedback effects. And so group outcomes that affect individual behavior in a way that the individual behavior, for example, reinforces these group outcomes and so on. So this would be a positive feedback effect. Now, if we want to do research that focuses on groups and social interactions, there are certain methodological challenges associated with that we don't necessarily have when we focus on individuals. So one of the challenges is, how do we define group boundaries? Everyone is connected on the internet. We all participate in different kinds of groups, on different kinds of social networks. How do we define where our social group ends? Another problem is, how do we gather data on interactions? And in particular, if we are to focus on groups, we also need to gather more data. Right? Now, we're no longer talking about 100,000 individuals, but we're talking about one group, for example. So, these are kind of unique challenges that, despite the kind of the enormous data we have online, digital trace data we have these days, we still have to deal with some of these problems. Another issue related to group level research is the problem with data heterogeneity. So this is not only about, so we have something similar with the individuals, the fact that we might have unobservable factors, for example, but for groups now we have a group of individuals, and they might differ in ways that we know, but it's very hard to account for. And this could be because groups attract different kind of individuals, so individuals self-select into groups, but then also certain other unobserved group factors could be producing different composition in the groups. Now, finally, there is also the kind of the inherent problem once you start thinking about interactions, is that by definition, you're focusing on non-independent observations. So how do we deal with these? So in this talk, I'm going to give you some clues. I'm going to use 3 projects that I have recently completed that exemplify how we can do research with groups, with online data, but then also address some of these challenges in different ways. So I'm particularly going to talk about 3 projects. One is in which we look at dyads, and in particular how the viewing of a profile picture forms a social interaction. Then I'm going to look at a project in which we use crowdsourcing contests to show a group effect, so how certain group incentives affect the behavior of individuals. And finally, I'm going to show you a network experiment that we designed online in which we look at emergent group outcomes. So let's start with the first project in which we looked at profile pictures on Facebook, and we used a survey experiment to do that. Now, a bit of background. Do you remember the Gaydar study? So this one came in 2018 and it caused quite a bit of controversy. So this study claimed that we humans, and actually even robots, so algorithms, can guess the sexual orientation of individuals simply by features of their face. Now, as a matter of fact, this kind of research, looking at how individuals can guess individual properties from pictures, has been done for quite a while in psychology. And psychologists have shown that we're better than chance guessing properties such as sexual orientation, personality, political affiliation, criminality, and intelligence, and so on, just from a picture of an individual, of their face. Now, how can we account for this? So the first instinct we might all have is, well, does this mean that there are certain biological markers of intelligence and criminality or homosexuality? Now, this controversial Gaydar study claimed that, but most psychologists would disagree with this idea. So they actually have another theory called overgeneralization that suggests that we have evolved to recognize features such as threat, emotional state, anger, for example, or rage, or familiarity. So we have evolved to recognize similar, our families and friends. But now we are kind of misattributing these properties to individuals who just remind us of these particular emotions. What we do in this study is we suppose another explanation. So we suggest that our perceptions are socially constructed. And this is based on Bourdieu's theory of the habitus, which represents our orientation towards the social world. And the idea is that the habitus, this particular social orientation we have developed through our upbringing, for example, that this is what informs how we present ourselves in the social world, but also how we perceive the social world. So when we talk about online interactions, this would suggest that social factors affect both how we present our online personas, but also how we perceive others. And in this particular study, we were interested in whether individuals could guess education from Facebook profile pictures. So we gathered information from participants on Amazon Mechanical Turk. We first collected Facebook pictures from about 112 of them, and then we asked another set of 700 to go over a subset of these pictures and to guess what was the education of the person on the picture. We manually coded these pictures to just have some description of what's happening in them. And then we ran some analysis accounting for the fact that we have individuals nested in guesses, and then also guesses referring to particular nested in pictures. Now, what we found was similar to what others have found, is that we are better at guessing, in this case, education, from pictures than chance. It's not much, it's actually only 61% compared to 50%, but there is still some signal in these pictures that we're able to read. We found some evidence that there are certain biases in how we perceive these pictures. There were some interesting findings related to the fact that higher educated people post more pictures online of themselves being outdoors, and also individuals are able to guess these correctly, that these belong to higher educated individuals, and that photography actually could boost up your education in a sense. But more importantly, what we found was that Facebook users with similar education guess better. So if I am shown a picture of someone who has higher education, I'm better at guessing correctly that they have higher education. So in a sense, there is a signal in this picture that me as a person who has gone through a similar upbringing, similar educational background, similar cultural kind of formation, and this information I'm able to read that others, outsiders, are not able to read, and vice versa for the lower educated individuals. So this project intended to show this idea to you, to demonstrate this idea that a profile picture on social media constitutes a social interaction. So basically, anytime we have two individuals, we can have this kind of unique communication occurring between them, even if they're not face-to-face interacting. And both of them are participating in a sense. Both of them are revealing aspects, but then others might be able to read certain information that depending on similarity, for example, in this particular case. So this would suggest that social factors would determine how people perceive and interpret any social information, right? So this is something to keep in mind if you do a survey, for example, and show participants certain text about others or even an image of others. This would show that not everyone necessarily would perceive this text equally, that their reading of this information would depend on their own social background. Now, this study looked at two individuals forming interaction online, even though they're not even communicating the way we usually think about communication. The next study, we are looking at group effects. So now we have individuals embedded in larger grouping, and we want to look at how the group, certain properties of the group could affect individual behavior. And we're using observational data to show this, and we're using kind of advanced causal inference techniques to have a bit more certainty about the causal effects here. This is a project about social comparison and individual performance. And social comparison means that kind of the tendency of us to compare to others. And it's actually something that is well familiar to a lot of organizational scholars and behavioral economists. And they have shown that anytime we compare ourselves to others, this makes us more competitive. And competitive actually could be something very good, especially when you think about innovation or boosting up effort, the average effort and performance. Now, in a lot of settings, the average effort and performance or the best performer is not necessarily something that we most care about. We might more care about the distribution of effort and performance. And so here you can think about education, for example, where we want all students to achieve their best and to comprehend the material, do well. And we don't necessarily consider it a big achievement if we have one outstanding student only. So social comparison in this kind of settings comes in the form, for example, of grading on the curve, a situation where your mark depends on how others perform. It's not on an absolute scale. American high schools, for example, also employ class ranks. They rank individuals, and this matters for acceptance to universities. Organizations employ something called stack ranking or forced ranking, where they would rank the employees in the team and use this to attribute bonuses, for example, or fire individuals. And then, of course, there is kind of the resurgence of gamification and the use of leaderboards or badges and reputations to incentivize individuals. And so what's interesting here is how do these different strategies for increasing social comparison could actually backfire when we look at the distribution of outcomes, in particular the effort and performance. So we used data from TopCoder, which is an online crowdsourcing platform for programming contests. So volunteers are given a programming challenge, a task they have to complete. And we're particularly looking at these challenges where they could submit a solution and then they get a feedback and they can repeat this until the challenge is ongoing. So in these challenges, the winners get certain monetary reward quite often, not always. Some of these challenges are designed to motivate the community and enable learning. In particular, in this project, we were interested in the challenges that use relative scoring versus absolute scoring. And relative scoring means that the feedback you get, the score you get, your performance in the challenge depends on how others perform. And absolute scoring would be when you evaluate it against some kind of exogenous scale, and every time you improve your score or your code or your submission, your score improves. Not necessarily that is the case with relatively scored challenges. So as I mentioned, we used kind of advanced causal inference techniques. We used what we call multi-level matching, where we started with the challenges and we differentiated between absolutely scored challenges and relatively scored challenges. And these challenges differ in a lot of other aspects, but we were interested in challenges that are similar in everything else apart from the scoring procedure. And so we could match such challenges, and we created these strata of challenges. So the challenges that are somewhat similar in, say, the duration, the type of task they give coders, but that only differ in whether the feedback you get is relative or absolute. Now, within a stratum, we wanted to identify individuals who had participated at least once in both an absolute score challenge and a relative score challenge. So in a sense, we want to find individuals who have been exposed to both the control and the treatment. So this is known as a crossover experimental design, and is something that's quite widely used actually in health and medicine studies. Now, once we identified these individuals, we could look at their submissions. We had the actual code they submitted, and we could use certain kind of software complexity measures to evaluate the sophistication of their code, so their performance, and also to look at how much effort they put, so how many code lines they wrote for this particular challenge. First, we looked at the level of the challenge, so at the group level, and we didn't find very strong kind of differences between the social comparison case or the one without social comparison. But of course, this could be because different challenges attract different kinds of individuals. This is the kind of the composition self-selection effect that's possible in these cases. And it could also be because the treatment has a different effect on different individuals, right? So we have a heterogeneous effect from the treatment. So to identify this, we look at now at individuals, those particular individuals who had experienced both the treatment and the control in a very similar challenges. And we looked at how social comparison affected their performance and their effort, and how predictable their performance was, depending on their ability, where we measured ability with their prior performance in these contests. And so what we found was that individuals who have lower ability put less effort when there's social comparison, while individuals of higher ability put in more effort. And so this produces a more extreme distribution of outcomes when it comes to performance when there is social comparison. And we also observe that lower skilled individuals have actually more predictable performance. So in a sense, they find it harder to overcome their disadvantaged position when there is social comparison. So in summary, what we found was that social comparison can have negative effects, and in particularly when we think about the distribution of effort and performance, and this has relevance to communities that focus on learning or member engagement, for example. Now, I particularly chose this project to not only show you how we can study group effects on individuals, but also to demonstrate to you that there is a lot of advantage of having a lot of data in this case. And we particularly didn't use all the data because we decided to use matching techniques where we could only use part of the data, but the data that we have very well vetted and identified very similar cases. And so This also allowed us to look at heterogeneous effects. And that's something that luckily big data allows to do now that we have so much information on so many individuals, and it's much harder to do with surveys. Okay, so this project was focusing on group effects, how the group, in our case, group incentives, affect individual performance. And in particular, we were interested in could these effects differ by the individual. Now, the next project, we're looking at group outcomes. So now we're interested in how do individuals' interactions combine to produce a group outcome that cannot necessarily be deduced by individual by the average individual. We cannot guess it based on the individual performance or individual outcome or individual preferences even. And we use the network experiment online to study this. This is a project about individual heterogeneity and how we can achieve fairness with that. So what we mean by individual heterogeneity is this idea that we are endowed differently. Some of us are smarter, some of us are stronger, some of us are lucky enough, more lucky to be born in a better socioeconomic background, and so on. Now we recognize this as a matter of fact, but when we look at outcomes such as popularity, wealth, income, power, we often talk about unfairness, talking about inequality. So is it possible to get fair outcomes from different individuals, and what does it mean? Now, when we look at individual interactions, so me interacting with someone else, behavioral economists and psychologists and even neuroimaging studies have shown again and again that we have a very clear idea of what fair interaction means. So in some cases, this might mean reciprocity. So I give to you, you give back to me. In other cases, it might mean equity aversion. So you have more, so I expect you to give me more. I have less, I'll give you less. Or it could also mean generosity. So I just have more and I'll unilaterally transfer to you because that is fair, right? But when it comes to the group level, so what does fairness mean in a group, especially when we have heterogeneous individuals? This is there's a lot of philosophical debate about this. So to begin with, there is this kind of straightforward idea that most of us are familiar with, the idea of meritocracy, and this idea that our rewards should correspond to our inputs, to our abilities, to our qualities. So in a sense, we would expect this kind of proportional linear relationship between our endowment and the outcome we get. Now, we can deviate from these ideal relationship in two different ways. So we can have a higher dispersion, or we can have more leveling. So we can actually have a lower correspondence between the endowment and the outcome. So with a higher dispersion, we can have more disproportionate rewards depending on the endowment. And usually these are associated with inequality and unfairness. But in terms of leveling, we can have, again, different situations, and not all of these are necessarily associated with equality or with fairness. So we can have equality of opportunity, this idea that the least endowed should be given opportunities and incentivized to outperform, basically, to overcome their disadvantaged background and to do better. This, again, might kind of erase differences between endowments, but in some cases, this is what most people would consider fair. Now, in Scandinavian countries, we have the opposite. We have the law of Vianti. You might also heard of the tall poppy syndrome or the crab bucket mentality. And the idea here is that those who are better endowed need to not show off. They need to diminish their kind of accomplishments and should not stick out. Most people would not consider this necessarily a fair outcome. And the reason is also that even in Scandinavian Nordic countries, the law of Vianti is present because actually it is combined with equality of opportunity, and this leads to equality of outcome. Now there is another theory that some of you might have heard about. It's Rawls' theory of justice. And it's interesting because it allows for kind of wealth concentration or this kind of disproportionate rewards to the most endowed, as long as we have equality of opportunity, right? So again, this is a kind of a long political theory tradition that has been well argued and well adopted. And it's just yet another competing theory of fairness at the group level. So what we set out in this project to do is that we wanted to see how these well understood, well tried ideas about fairness at the individual level add up to global outcomes, and are these outcomes fair, and in what sense are they fair? So we did this with an experiment. So we worked with Science at Home, which is a citizen science platform at Aarhus University. And they have done games before, and they developed a game for us called Urbanizer. And in this game, you're given a block, and your goal is to build this block as much as possible to become a major city hub. And you have a certain number of resources. So in our case, different individuals had different number of resources. They were randomly assigned to that number. And here you can see the resources that others have, as well as your resources. And you could invest these resources in yourself, in which case you get 10 points, or you can give them to someone else, in which case this other person gets 15 points. So this is how you can develop these mutually beneficial reciprocal exchange relations with others. But there is, of course, a risk, because you might give to someone that might not reciprocate necessarily. So what we manipulated in this experiment was whether you could view the endowments of others and whether you could view their score, or that would be the wealth. So this is just an image to show you that individuals interacted over time, and their score increased over time. Some of them established relationship with others. Others were investing in themselves mainly. And also there were individuals with different endowments, so that would be the color of the nodes. And in the end, we looked at the outcomes at the group level. We looked at the dispersion of outcomes. So we used the Gini coefficient, which is a common measure of dispersion, especially in the context of inequality. And we looked at how endowments and outcomes correspond to each other. So again, this idea of leveling, and this idea that maybe in some cases, it is actually desirable not to have this perfect correspondence when we think about equality of opportunity, for example. So what we found in this study was that when outcomes are visible, the dispersion of outcomes is lower. And that's because all players give more and reciprocate more with those who are poor. So there is some kind of charity aspect to it, that everybody was giving more to the poor. When endowments are visible, we found that this results in better equality of opportunity. Because what happens is that others give more to the least endowed, and this makes them cooperate more. And so they contribute more, but then they also earn more. And in a sense, they deserve what they earn, and this improves their outcomes on the average. Now, I use this particular example not only to look at you, to show you how we can study group level outcomes, such as these kind of complex ideas of fairness at the group level, but also as an example of how we could use games and also gamification to gather more data, which was one of these challenges about studying groups instead of individuals. So there are already a few very successful and good examples out there where scholars have used gamification in particular to engage citizen scientists. So they would advertise this through popular media or through social media, and collect volunteers to drop in and play a game or learn something about themselves. And that's how they could contribute data, and you can get hundreds of thousands of individuals who would normally not be able to recruit via our traditional channels, such as the undergraduate experimental population, for example. But of course, what we're working on now, so the experiment I showed we actually did on Amazon Mechanical Turk, but we've been also trying to work with schools, in particular in Denmark, of where we could use this game to both teach individuals about social research and also about social topics such as fairness, inequality, groups, and then actually use this interactive lesson to collect data from these individuals. And again, this would allow us to collect more data and also from populations that we don't normally reach. So there is a huge potential here that I think we need to work more on. And I think that's also an area that most of you might benefit from. So to summarize, I presented 3 projects in which I tried to show you that there is potential in thinking about social interactions and groups. We can learn more new things about the social world, but we can also kind of, this approach could also inform, even if you work with individuals, could inform you how to do better research with individuals. Now, if you're interested in this, in summary, I think the key point here is that that you need to look for non-independence. And it's actually easy to find non-independence because anytime you have 2 individuals, they form a social interaction, whether we're talking about 2 people or a bot and a human, or whether you're talking about an image of a human and a real person, and so on, right? So you should always think about it as a social interaction, and the fact that you might have kind of input from both sides, even if you think of one of them as being non-human-like. Another message I'd like you to take home is that there are almost always group effects. So every time you have information about others, that's a group effect, right? And you can study that, you can control for that, or you should control for that, right, or this could be what you're particularly interested in. And finally, I also wanted to kind of bring your attention to the fact that sometimes some group outcomes cannot be just produced by averaging individuals, that they're emergent outcomes that are worth studying, and a lot of us are studying those. So here you can think about collective action, so protest, for example, inequality, even polarization, segregation, or echo chambers, right? These are things that we have to inherently study at the level of interactions and groups, and it's impossible to just focus on single individuals or random sample of individuals to understand some of these phenomena. So with that, I'd like to thank you and thank my collaborators with whom I worked on these projects I presented, and the funder, Volkswagen Foundation, who was responsible for funding most of this research I presented. So thank you very much, and I look forward to our discussion.